Welcome back to my tutorial series on how to make a game using Flutter and Flame. In this episode, we're adding in this little chicken right here that if he becomes in our line, he's going to chase after us, and that's no good. If he catches us, we're going to have to respawn, but we can actually jump on top of his head to destroy him and beat the level. We've got a lot to do, so let's get started. To get started, first we need to grab the asset packs that we'll use for our enemies. I will put a link to it in the description to the itch.io page. It's from the same creator that made the assets what we've been using for our games. He's made a lot of different enemies on here, so we can go here, click download now. No thanks, just take me to downloads and then download the asset pack, which is really nice. Next, what we need to do is we need to get a sound effect for when we jump on top of the chicken that we actually play a bouncing sound effect. The effect that I did is I just hit power up and just kept hitting power up until I got a power up that I liked and then hit download. Again, I will put a link to my power up in my GitHub project, so you can definitely download that if you want to, or just create a different one, whatever works for you. Now we can go back to our code. We can open up our assets images, right click our images, and then go to Reveal in File Explorer. This will open up our images. We can double click to open up our images folder, and then we just want to open up the zipped file of the Pixel Adventure 2 that we downloaded, and we can go ahead and grab in the enemies folder and drop it into our images folder. We also then want to go back to our assets folder and go into our audio file, and we want to drag in the power up that we downloaded, and we can rename this to bounce because this is what we'll use for our bounce sound effect. Now that we have both our images and our audio file for our bounce, we can close out of our Explorer and then just make sure that we go into our pubspec YAML folder, and then with our images we can go ahead and duplicate this line, and then we can make sure that we bring in our images enemies, and then since we're using our chicken, we can do enemy/chicken/ and hit Control S to save it so that we can grab in those images. Once our images are added in our pubspec YAML, now we can go over to tiled so that we can actually spawn in our chicken. So what we're going to do for now is we can just get rid of our saw that we have in this location by selecting it and hitting delete, and we can go ahead up to the square icon, insert rectangle, or hit R, and then we can drag out where we want our chicken to be. So we'll start our chicken right here. Our chicken is a 32 by 34, so you want to drag out 2 squares by 2 squares so that it's 32 by 32, and the little overage is completely fine. With our chicken selected, we want to go, well, with our selection area selected, we want to go over to class, and we can call this chicken with a capital C, and then we can also give the name chicken as well, just so it tells us that this is a chicken. We do want to also add in some custom properties, just like we kind of did with our saw. We have the off neg and off pause. We're going to do the same for our chicken. So we can come up here and do the select objects just to make sure that we're selected on our chicken. If you select away, and then we can click the little plus sign down here to add a property. The property we're going to add is going to be a float, and we can do off neg, capital N, and then we can do one more property. This one is going to be off POS, capital P. Now for the off negative, if you don't remember from our saw, we want to count how many squares we want our chicken to move. However, with our chicken, we want to consider it specifically in the middle. So we want the left of our chicken to be 1, and then we're going to count from there. So the square right here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then instead, if we didn't count for the chicken, it would actually be 11. So we want to make sure that our off neg is 12. We want to do the same for the right side of our chicken, or the positive. So we'll do 1, 2, 3, 4, and 5. So our off neg for the chicken in this scenario is 12, and our off pause is 5. Keep in mind, this is just based on where you put the chicken. If you put the chicken here, those numbers are going to be different. So make sure that you correct them based on where you put your chicken. Keep in mind that you're counting from the very middle of your selection block. Count left and right from the very center, not after the chicken like we did with the saw. Now that we've done that, we can go ahead and hit save, and then we can go back to our code, and now we can start spawning in that chicken, which you probably already know how to do. The first thing we're going to do is go into our lib folder and go to our Pixel Adventure. Please make sure that play sounds is false. We do not want to play any sounds because in my last video, If you don't turn that to false, it will break your game every time you refresh. So we can turn it to false and refresh so that we're not playing any sounds. We'll fix that later if we have to, but right now we don't need any sounds to play. Now we can go into our components folder and then go into our level.dart, and we want to come down to where we're spawning in stuff, and we can go ahead and add in another case for our chicken. So the case is going to be chicken. And then just like we've done before, we need to go ahead and bring in a class for our chicken. So now that we have the level file there, let's just go ahead and add a break. We can hit save, and then here is where we're going to add in chicken. Cool. So we can go into our components folder, right click and go to new file, and we will just call this chicken.dart because it is our chicken enemy and it's the only thing we're going to have called chicken. We can do class chicken, and then our chicken is going to extend a sprite animation group component. And the reason why it's going to extend this is because we're going to add in like state, kind of like we did with our player, because our chicken is going to have different states. It's going to have a state when it's chasing the player, or when it's idle, or when it gets hit. So by using a sprite animation group component, it's going to make it very easy for us to be able to do that. We then also want to do our constructor, so we can do chicken, and then we also need to pass in our position and our size just like we did before. Now, thanks to some fantastic people watching my videos and know a little bit more about Flame and Dart than I do, they actually taught me a shorthand, so I appreciate you doing that. If you're going to pass something in as a parameter as well pass to your super, you can actually shorthand that by just calling super dot and then whatever you're going to pass in. So we're going to be able to pass in our position, but we also then want to pass it to our super, and we can save a step by just doing super dot position and super dot size rather than position and size and then super and then position equals position, size equals size. We no longer have to do this step by just calling super dot. Very useful. Didn't know that was possible. So again, thank you. A few of you actually told me that. So I'm glad that I can finally bring that in the video, and I appreciate you sharing that with me. So now that we're passing in the position and the size, we also want to be able to pass in our off neg and our off pos, negative and positive. So we can do final double off neg and then final double off pause. And then we do need to pass these in as well, but we need to set them just in case we don't set them by default, and we can do this by calling this dot off neg and then setting it to 0, and then we can do this off pause equals 0 as well. So these two we're going to pass in, these two we can pass in, but if we don't pass them in, they're going to be 0. That just kind of helps out with some bug fixes in case you forget to pass it in. It doesn't break your game. Just make sure you pass them in because you need them if you want your chicken to move in this scenario. Perfect. So we can actually save this now. We might not have to do much. So we can go back. Well, actually, let's do this way so we can at least see that it's working. Let's call our onload. And in our onload, we're going to call debug mode equals true. This way we can just make sure that we're passing in the correct information. We can go back to our level, and now what we can do is we can get rid of this comment that says add in chicken, and we can actually add in our chicken like we normally do. So final chicken equals, and then we'll do chicken. And then the chicken, we need to pass in our position and our size just to save ourselves some time. We can copy paste this. But another cool thing about calling super dot position is you actually get a type now, and it says that this type is going to be a vector 2. Whereas if you look on like when we did the passing it to our super, it doesn't know what it is. So it actually says dynamic rather than vector 2. So again, another good reason to use the shorthand code super dot so it passes in that information that we need to have. We also need to pass in our off neg and our off pause. So we can do that by doing off neg, and then we'll do off pause. Now we need to get reference of our off neg and off pause, and the way to do this is we can get an access to our properties. We can do final off neg equals, and then we grab in the spawn point dot properties, and then we'll get the value of the property, which in this case for off neg is off neg. We can then Alt Shift down to duplicate this line, select off neg and hit Control D. This will allow us to select it in both spots, and then we can do off pause. That way we can quickly change it here and here. And then here we just need to copy off neg and off pause so we can pass in those two variables. And then of course, make sure after we've created our chicken that we go ahead and add the chicken to the game by hitting save, by hitting add chicken and then saving. If we refresh the screen, we should see our chicken. There we go. It's invisible, but he's there in spirit for now. And now we can go ahead and actually bring him in and start customizing our chicken. So we're kind of good with the level.dart. We can close out of that, and now we can go back to our chicken. Now with our chicken, we're going to need to pass in a lot of different things. I'll try my best to do them when we need to, so that I don't just overwhelm you with add all of these variables, because why? So what we can do here first, we are going to want to set up our animations for our chicken so we can actually see our chicken. And I'll try not to say chicken anymore because I'm realizing that becoming annoying. So first what we'll do is we'll do underscore load all animations. And this is going to create a method by hitting Control period. We can create a method to create and load all of our animations at start. Because we're using animations and we're using a sprite animation group component, we are going to handle state as well. So we want to come up right before our class and do enum, and then you can call this whatever you want. Just make sure it's a capital letter. We're just going to call it state. And then we can pass in the 3 different states that we're going to have: idle, run, and hit. So that will link these to our animations. Again, very similar to how we did it with our player, we're doing the same with our chicken. Sorry. So with our load animation, the first animation we're going to have is going to be an idle animation. And the idle animation, we need to set it to an actual animation. Now, because we're going to use the same type of information for our animations, we can do like we did before and create an actual method just to make it easier to type. So we can do sprite animation, and this is going to be sprite underscore sprite animation. And then it's going to pass in a string, which is called state, and then an integer or int, which we will call amount. Just like what we did before, this is nothing new, so I'll try to speed through this. But we're going to return our sprite animation dot from frame data. And then we're going to need to pass in the, let's comment this so we don't get an error. We need to pass in our image and our data. Well, anytime we use images, we're going to grab them from our game, from our cache. So we need to come up to the class and do with has game ref and pass in our pixel adventure. Perfect. And now for our image, we can do game.images.from cache. And then we need to pass in the animation that we're using for our chicken. So if we go to our assets, images, enemies, it's going to start in images, but we need to go to enemies. And then we have a lot of different enemies. Please let me know what enemy you'd like to see next. You can also see kind of what they do on that other on the itch.io page. So let me know what enemy you'd love to see next. There's so many that we can choose from, but we can do enemies. So it's going to start at enemies, and then we're going to do the chicken, and then we can do /chicken, and then we're going to Alt Z so it loops, so it wraps the text, but we're going to pass in the state now, which you can see here. These are the 3 different states. So we can do $state, and then we're going to do space 32 by 34 and parentheses, and then after that we'll do .png. So again, we're essentially, instead of saying hit, idle, and run, we're going to pass in state to do that, and then we're just grabbing the rest, and they're all named the same. Perfect. Now with our data, what we need to do is we need to do a sprite animation data.sequenced, because this is a sequence data. We can add a comma here to make it easier to read. And then we need to pass in our step time and our texture size. So we can come up to the top here, right above our onload, and pass in those variables. We can do static static const. And then the first one is going to be step time, and by default these are 0.05. That is based on our animations. That's part of the itch.io page. They run at 0.05 or 50 milliseconds. We can also then do the tile, the texture size. We can do this by calling it final texture size equals, and then it's going to be a vector2, and they're all 32 by 34. So we can pass that in, and now we're no longer getting those squiggles that these don't exist, and because we're passing that information in. So that's all we have to do to actually create our method sprite animation, and now we can uncomment our idle animation and actually pass that in. So the sprite animation, the state that we're going to pass in is going to be idle. And then the amount that we're passing in, we need to see how many frames it is. So if we click our idle animation, it's 2, 4, 6, 8, 10, 12, 13. So there's 13 frames. And then we can pass that number in here, 13, perfect. And by default, this is going to loop. So we are good there with it looping. We can have it loop and not have to change anything. We are getting an error on our underscore idle animation, and the reason for this is I completely forgot to actually pass it in at the top. Sorry about that. So we'll do late final sprite animation, and then we're going to have idle animation. We can also alt shift down twice to duplicate these, and then we can do underscore run animation, and then underscore hit animation. So those are all three of our animations, and now we have access to our idle animation here. Now what we want to do is with our idle animation, we can alt shift down 2 more times because we know we have 2 more animations. The next one is going to be run animation. The state is going to be run. Again, it's just the naming convention here. And then the amount is 2, 4, 6, 8, 10, 12, 14. So the amount is going to be 14. The last one is going to be underscore hit animation. This one is going to be hit. And then the amount of frames, and this one is only 5. Now this one will not loop. So what we can do is we can use the cascade operator by doing ... loop, and we can set this one to false. So all of these are loop is true, but if we don't want loop to be true, we can pass in loop false by adding the ... So it essentially says, do all of this, but change something, aka loop equals false, which is perfect. Now that we have our animations, what we need to do is we need to set our animations to an actual group. So we can do animations, plural, equals an object. Make sure you have the semicolon. And then we can set these to our states. So state, which is our state up here, not just a state, but we named it state. So state.idle, do a colon, is equal to our idle animation. State.run, colon, is equal to our underscore run animation. And then of course, you know the last one, state.hit, is pretty much equal to our hit animation. So that's how we go ahead and link all of our animations to the state. So we don't need to change our animations, we just need to change our state, and then it'll automatically change our animations. And then of course we can give it a default state, current, which is the default, which is the current animation. Current is equal to state.idle. And if we save this and refresh, we should actually see our chicken. Perfect. There is our chicken. Sorry, again, with the chicken. Cool. So now that we've done that, what we want to do, there's a lot that we can do. The chicken doesn't move or anything like that. It doesn't know our player exists. So we can actually go ahead and start factoring in, the player and all of that. So what we can do is on our load, right here on our onload, we're going to create something else, and this something else is going to be underscore, we can call it calculate range. What we want to do is we want to calculate the range that our chicken can essentially see, and then if our player is inside of that range, then it's actually going to do something. So we can hit control period to create a new method. This method method is going to be calculate range, and then we can start adding in the information that we need to calculate the range. Now we've kind of already did this with our sol. I just didn't call it calculate range. So what we can do is we can pass in the information that we have so that we can get our range negative, which is what we're going to create, so that we can use that elsewhere to see where a player is. So this is kind of just like a little helper method so that we can grab the information that we want. So we can come up here right at the top. We can do double range neg equals 0, and then double range pause equals 0. And then we also, that's actually all we need right now. So we can come back down here. So our range neg is going to be equal to our position, the chicken's position dot x minus the off neg that we're passing in times, and then we want to multiply this by our tile size, which is 16. We don't actually have tile size made yet, so we can actually do that. We can come up to the top and do static const tile size. Again, it's just and it's 16. It's just very important that you use names. So when you come at this in the future, why did I multiply it by 16, right? You don't want a random number there. Magic numbers is what they call it. Well, I'm multiplying by the tile size. Perfect. And then we can do the same for range pause. So range POS, we're going to take the position.x plus, because we're going the other way, plus our off pause. Cool. So we're essentially grabbing the position.x, which is the leftover player, and we're going to subtract the off neg, which in this case is 12. So it goes about here. It actually goes 1 over, but that's perfect. And it's going to multiply these numbers by 16. So it's counting how many there were, which I think is like 11 from our x, but we want it to do 12, so it's like right here when it multiplies it by 16. Perfect. And then the same with our range pause, we're taking the x of our chicken, which is right here, we're adding however many numbers, which will get us to right here, and then we're multiplying that by our tile size, essentially. So that's how we can get this, again, range of where the chicken is going to look and actually go to, which is really nice. Cool. So now that we've calculated our range, what we can do is we can actually use it. So to use it, we can come down to, we don't have it yet, so we can make an update, call the update, so we can override our update function. And now what we can do here is we can update our movement. So we can do underscore, we'll just call it movement. I'm not good with naming stuff, but that makes sense. We can do control period and create a method. And now we can go ahead and add in what we want to happen with our movement. All right, so with our movement, first thing what we want to do is we want to set our velocity to 0. And we currently don't have a velocity, so we can actually come back up to the top and create the velocity. Again, we're pretty much doing the same thing that we've done with our player. We're not doing much different. We're just doing it so it works with our chicken or whatever we're doing. So we'll do vector2 velocity equals and then vector2.0. So we're going to set it to 0 by default. And then what we can do is we can now use it. So we will do velocity.x because we're working only on the x, not the y. Our chicken can't jump or anything. So it's just working on the x. Velocity.x is going to be equal to 0. And now what we need to do is we need to actually get access to our player so we can check to see where a player is going to go and stuff, right? So what we can do, well, actually, let's go ahead and let's just set up our positions. Position.x plus equals our velocity.x, and then we're going to multiply that by delta time. We do need to pass in delta time to our movement, and then we can pass that in up here as well. Forgot to do that, so pass it in the movement so that we can use it in the movement. If we save and reload this, let's see what's going to happen. So nothing happens, good, but we are taking our position.x plus equals our velocity, and right now we don't have a velocity. Our velocity is 0, so nothing is happening. But what we can do now is we can actually change our velocity based on, well, we could just change it if we want to right now. We could do velocity equals 80, and now our chicken's going to go to the right. Or if we do negative 80, now our chicken's going to go to the left, right? But we don't want it based on that. We only want it to do that movement if our player is in range. So to do this, what we need to do is we need to get an easy reference to our player, because we're going to have to write game.player a lot, and we don't want to have to do that. The less code we can write, the better. So we can come back up to the top, and we can do, we'll put it right here with the rest of my lates. We can do late final player is going to be called player. This player is a reference to our player, so we can control period to grab the import the library for our player. And then on our onload, what we want to do is we can just set player equals game.player, and we're getting access to game by having that game ref. So essentially this is just saying, instead of letting me have to write game.player every time, I can just write player, just a little bit less code. So now that we've set our velocity down to 0, what we want to do is we want to get access to our player. And the one way that we can do this is we are going to need to do, so if you remember, we flip our player, right? If our player is going to the right, his scale is one way. If he's going to the right, left, his scale is another way, and we're going to have to offset that. And I don't want to kind of show you why we have to do that, because it gets more complicated. So I'm just going to show you the fix, because it took me a while to fix it. So what we'll do is we'll do double player offset, because we're going to have to offset it based on which way our player is going. And then we're going to pass in our player.scale.x, and we're going to check to see if it's greater than 0. If it's greater than 0, it's going to be 1, which means our player's facing to the right. So if it's greater than 0, we just want to make this player offset to be 0. And then if it's not greater than 0, which is what the colon is, we're going to make it negative player width. And if you remember in a previous video, we have to offset based on where a player is facing. Hopefully you watched the other video, but I'll explain it real quick. So right now, our player's X is right here if he's facing to the right. If he's facing to the left, his X is right here. So now we need to get this side of our player, and we do that by taking his X minus his width, so we get to the left side. Hopefully that makes sense. I know it's complicated. I wish we could avoid it. It gave me a lot of headaches the other day trying to figure out how to do the offset. This is the easiest way to do it, so let's just do it that way. Cool. So now that we have our player offset, what we want to do is we need to check to see if our player, we can do if player in range. Now, if our player is in range, this doesn't exist yet. So what we can do is we can create another, essentially a helper method that'll allow us to calculate if our player is in range. So let's go ahead and do that. So we can do bool, because it's going to return true or false, and we'll call it player in range. And then what we need to do is we need to essentially do our player offset. So we can just copy this again, because we are going to need it, so we can calculate where our player is. And all we have to do is kind of like what we did with collision a little bit. We're just checking different variables. So what we're going to do is we're going to return, and it's either going to be everything is true, which will make it true, or something is false, which will make it false. And what we're going to check is we're going to check if our player.x plus our player offset, which is going to be 0 if we're facing right, negative our width if we're facing left, is greater than or equal to our range neg. What this essentially means is if our player X is greater than, right here is our range in this scenario, right? The chicken is moved, but the chicken is looking to this location. So if our player is greater than, which means he's to the right of this little section right here, now he's in range. That's exactly what that means. We're then also going to check and, so it also has to mean that our player.x plus the player offset is less than or equal to our range pause. And again, this is the exact same. We're offsetting our player to make sure, but we're essentially, I try to make it as easy as possible, but we're essentially checking to see, is our player here, or is our player here, or anywhere in between here and there. And that's all we're doing. We're checking to see if the range neg, which is the furthest the chicken can see, is here, or the range pause, the furthest the chicken can see, is here, or are we anywhere in between this spot and that spot? If we are, then we are within the range. And that's exactly what we're doing with the greater than and equal or the less than equal. I hope that makes sense. It does make sense to me. It took a while to figure that out, but all we're really doing is we're putting it into code. Is he here, or is he there, or is he in between? And that's what this code looks like. Now, we also don't want to just check to see if our X is in there, because if our X is in there, if he's up here next to our cherries or anything like that, or in the middle, it's going to track that. So we also need to make sure that we're tracking if our player.y plus our player.height is greater than our position.y, which is the top of our chicken. So the player.y is the top of our player plus the player.height. Now we're at the bottom of our player. If the bottom of our player is above the top of the chicken, well, now he's in range of the chicken. And then the last one we need is if our player.y is less than our position.y, the top of the chicken, plus the height of the chicken, aka the bottom of the chicken. So if the top of our player is above what was less than, which is up. So if the top of our player is above the bottom of our chicken, he's within range of our chicken. And I hope that makes a lot of sense. Essentially, I can show it to you just a moment here. We'll see it in code, of course. But what we're doing is if my player is right here, the top of my player is above, right, is up above the bottom of the chicken. Great. The bottom of my player is further down than the top of the chicken. Great. And then my X is within that range, right? So if I would jump, or if I'm over here, even if I'm over here, I'm still meeting the X, but I'm not within this little block, right? I'm not within this block of the chicken on my Y. My Y is not on the same level of the chicken. Therefore, I'm not in range. Hopefully that makes sense. And then all of these are going to check. They all have to be true. They all have to be false. They all have to be true. One has to be false for it to be false. All have to be true for it to be true. Cool. So now, don't hit refresh. Now what we can do is we can come back here and we can say if and now we can just return that. That's going to either return true or false. So we can say if player in range, make sure you have the parentheses. Now we can say player in range. Player is going to be in range of the chicken. So if we save and refresh, no errors, perfect. And now we can actually say that our chicken is within, our player is within the vision of the chicken. It's on the same level of the chicken, and it's within the range that we've determined that our chicken can see. So what do we want to do? Well, what we want to do is we want to tell our chicken to go towards our player. And to do this, we can actually come back up to the top and we can create a new target position. So give me one moment here. We're going to bring it right here. We're actually going to create two of these. So we'll do double move direction is equal to 1, which by default would be the right because positive goes to the right. And then we'll do double target direction equals -1. And I made it -1 because by default our chicken faces to the left with the animation. So I want him to go to the left first. Doesn't really matter, we're going to change it, but that's why it's -1. Because I want him to go to the left first if he was going to move, but it gets overridden, so it doesn't matter. So what we can do here then is we can do, if our player is in range, we want to set our target direction to be equal to our player.x plus our player offset. But only if it's less than our position.x plus, and now we need to do an offset for the chicken because again, we're pretty much handling the chicken, or we haven't gotten there yet. I'll show you in a moment when it starts moving, but we need to offset our chicken because if he's going to the right, if he's facing to his right, his scale is going to be different than if he's going to the left. So we need to do the same thing. So we can do double chicken offset, name this whatever you want. If scale.x is greater than 0, then the question mark, it's going to be 0. Otherwise, it's going to be negative width, which again is the exact same thing we're doing with the player. We're just doing it for the chicken, and then we're going to add in our chicken offset. So what we're saying is if we need to check first, is player.x plus the player offset less than our position.x, the position of the chicken, which is the left side, plus its offset. If it is, then we want this to be -1, aka go to the left. Otherwise, we want it to be 1, aka go to the right. So this is an easy way for us to do kind of like 2 if statements in a moment at a time. We're going to check to see if this is true or false. If it's true, it means he should go to the left. If it's false, he's going to go to the right. And that's our target direction. And now what we can do is we can actually do our velocity.x is going to be equal to our target direction times, and then we need a run speed, how fast our chicken is going to run. So we can make this whatever we want. We can come back up to the top. We'll do static const run speed equals, and then we'll just make it 80 for now. You can make this faster if you want. But we're going to make it 80, and then we can do times run speed. Perfect. And then what we need to do is we now need to, well, we can actually save this and reload, and let's see what happens. So there we go. Our chicken is now running to our player. Now he's not flipping yet, but our chicken is, if we're in range, as you can see, I'll make it big. As you can see, when our player is in range where it's supposed to be, he's on the same level as the chicken, which means the chicken is able to get him. But when we jump, he stops, which is awesome. We don't want him to move if he's not in range, right? You could technically add another type of logic in there. We'll slowly walk around and all that, but this is complicated enough. But now when our chicken gets to us, it's going to follow us, and we can still run a little bit faster than the chicken, which is good. Tweak the speeds if you want to, but now our chicken actually goes towards our player, and the moment we're out of it, it goes the whole way to the end. But the moment we're out of it, the chicken won't follow us anymore. So if we quickly jump over here, that's it. He won't go any further. Cool. Now, a few things that we need to change. The first thing that we need to do is we, of course, need to make it so that our chicken will face the direction that we want. So what we can do is we can come back up to the top, and we can go ahead and create a double on here. Let's see where we're going to put it. We'll put it right here with all of our other doubles. We'll do double. Actually, we already made the move direction. Perfect. So we don't have to. So we can take this move direction, which is, I knew I made it for a reason. We can take this move direction, and then what we can do is right below where we've moved, we can change our move direction to equal, and what we can do is we can lerp double. And what lerp does is essentially does something over a period of time. Just so it's not instant. I don't necessarily if we need to do the lerp double here, but I was getting some errors where it's happening immediately, and then it just keeps flipping back and forth and back and forth and back and forth, which I don't want. So by doing that, we can delay it a tiny bit by just doing a lerp duration, lerp double. And what we're going to do is we're going to take our move direction compared to our target direction, and then we're going to just pass in 0.1, which is a very small number. And then we're going to say if that doesn't exist, question mark, we'll pass in 1. And the question mark essentially means if this is null, then I think that's what that means. If this is null, if this doesn't exist, if this fails, then just use 1, essentially. I don't know if it's checking if it's null, but if this fails, then use 1 is what that means. Perfect. So now we have the move direction. So what we can do here is we can actually use that to flip our chicken to face the direction that we want. So we can come back up here in our update, just like what we did before. We can do underscore, and then we can call this update state. And then we can do control period to create a method. And then we're going to update our state of our chicken. So like we did before, what we want to do is we want to set the current state to be something. So we can do current equals, and then we can do another ternary here where we can do velocity.x is not equal to 0. And what this means is if velocity.x is not equal to 0, then we want to make it where it's state.run. Otherwise, we want it to be state.idle. And essentially what this is doing is it's checking to see if our velocity.x is 0. If it's not equal to 0, then we're going to make our state run, which means if it's not 0, it's moving. So let's use the run state. Otherwise, if it is 0, then it's going to be the idle state. So this is going to allow our chicken to actually move. If we save that, you can see now he's automatically just switching to our run animation because he's moving. Now what we can do is we can use our move direction to actually make him face a certain way like we did before. So we can do if, and then we need to check two different things here. So we'll do another parentheses, and we'll do move direction is greater than 0 and our scale.x is greater than 0. Now this is a little different than our player because our player by default faces to the right in its code. Like the image of our player is facing to the right, whereas the chicken is facing to the left by default. So we need to make sure that we compensate for that. Scale.x is greater than 0 for our player makes him face to the right, but for our chicken actually makes him face to the right. Is facing to the left. So if these are backwards, we need them to be backwards. So just keep that in mind. Or we want to check to see if our move direction is less than 0 and the scale.x is less than 0. Again, backwards from the player, then we can flip horizontally around center. And what this is going to say is if we're moving to the right and we're facing to the right, then we need to flip horizontally center. Or if we're moving to the left and we're facing to the left, because again, our chicken is backwards, then we need to flip that. And if we save that and go down now, our chicken is going to switch. And I'm pretty sure that little lerp in there fixes this issue. As you can see, I do want to show you this issue. It would be much faster if we didn't have that lerp. Still a problem, but we'll fix that because we'll never directly be inside of our chicken because of collision. But now you can see when we jump over our chicken, it actually pauses for a moment, then reconnects to where we are because it's not tracking until we're in that line of sight, and then he flips the position. Again, chickens are kind of, no offense to chickens, but they're not the brightest. So at that point, where did you go? I really like that effect because when you jump over him, he has no idea where you are. Then it, quote, hears you and then turns around and then chases after you. So very cool. But now we have our chicken actually chasing our player. Now it's time for us to probably add in collision. So great, let's go ahead and do that. All right, so to add in collision, we can go back up to the top and we need to add in a rectangle hitbox so that we can actually add collision. However, first we need to go to the very, very top and tell our class that it actually has collision callbacks. If you don't add that, there is no collision, so make sure you do that. And then right under our player, where we bring in a reference to our player, we can add a rectangle hitbox. And then what we want to do is we want to kind of stylize this hitbox to fit where we want it to be for our chicken. So we can pass in a position. The position is going to be a vector 2. We're going to make it 4x6. You can technically just add any numbers you want and then tweak it later. That's kind of how I came across these numbers. And then we'll also do a vector 2 and then the size for size, and the size is going to be 24 26. And if we save that and now we have to refresh because it's an onload, if we make this really big so you can see it, this is kind of the outline. It's completely equal on the bottom, but a little bit closer to the chicken head on the left, kind of where the chicken head is on the right. Again, you can tweak this and not all of the chicken tail. If you wanted, you could make it go right to his butt, but that is good enough for what I wanted it to do. But again, feel free to tweak the size or the position. The position goes where it's positioned, and then the size is how far it goes. So that's how you do that. But we now have access to our rectangle hitbox. So what we can do now is we need to check to see if our player collides with it. So we can actually come down here. We can actually do it right at the bottom. We will do void collided with player. And we are actually going to make this not an underscore so we can call it later in our player's code. Because the cool thing about this is we can create methods in our chicken and call them in our player, or create methods in our player and call them with our chicken, which is really cool, but you just have to make sure that there's no underscore so it's public so you can call that. We're also going to do some awaits here so we can make this async so we don't get any errors. So with us calling collided with player, what we can do, just so it works right away, we can go into our player code and we can actually do that. So if we go back to our player.dart, we can scroll down to where our player inner on collision start. We can do if other is chicken. Make sure you hit enter to import that. Then we're going to do other dot collided with player. Now there's probably a better way for us to do this. We could really check to see if other dot collided with player exists, and if it does, call it. But right now we'll just keep these separate so you know which one is doing. Very good for testing, but in the future we're not going to do this for every single enemy. We can just say, hey, if it's this, then if it has a collided with player, just call it, right? So we can hit save there, and then we can go back into our chicken. So now when we actually collide with it, our collided with player is going to call inside of our chicken class. And what do we want to do when it collides? Well, this is going to be a collision at any point in time. And collision, this is the built-in collision, not the collision we made for the things. So anytime essentially our square overlaps the chicken square, it's going to collide on the very first time it does it because it's on collision start. So what we can do is we can check to see how that collision was. And then based on how that collision was, then we'll do something. So what we can do here is we can check to see if our player's dot velocity dot y, so that's not the x but the y, is greater than 0, which means our player is falling. We don't want our player to be able to stomp on our chicken if he's jumping from beside him, right? That doesn't make sense. We only want him to be stomping on our chicken if he's coming from above. Well, if he's coming from above, that means his velocity.y is positive because he's falling. And we want to check to see if our player.y plus the player.height, aka the top of our player plus the height, aka the bottom of our player, is greater than our position.y, which is the top of the chicken, right? So we want to make sure that A, our player is falling, his velocity.y is greater than 0, and B, the bottom of our player, when it's collided, is actually greater than the top of our chicken. That way, no random weird things can happen where somehow we're falling, but our head hit the bottom of the chicken. We don't want that. We want the bottom of our player to be above the top of our chicken, possibly even gone into the top of the chicken a little bit when it's triggered, which is greater than position. So if that happened, then our chickens got stomped on. Our chicken has been stomped, right? So what we can do is we can come up to the top. We can actually do a Boolean to keep track of that. We'll put it right here, bool, and we'll just call it got stomped. By default is going to be false, but we're going to set this to be true when our, well, player stomped the chicken, right? Sorry, but you got stomped. And I hope that's not trademarked by by Mario. But it got stomped. So we're going to set the got stomped to true. Now, if it's not true, then what we want to do, which means we did not fall on top of our chicken, what do we want to do? Well, we just want to call player, and we want to tell our player that it's collided with an enemy. So we can go back into our player file, and we can go down, we'll just go to the very bottom here. We're just going to do void, and again, don't do the underscore, but collided with enemy. This lets our player know that, hey, you've collided with an enemy. And what do we want to do when we collide? Well, we just want to respawn. And I want to show you this concept. We can keep respawn private. We don't need to make respawn a public method. What we can do is we can create another public method that would call our private method as long as it's in the thing. So essentially from the chicken's page, it's saying, well, I'm just saying I collided with an enemy, right? I'm telling the player that it collided with an enemy, and then inside of the player class, we can say what that's going to do. Depending on what your class is, that might be completely different, but all we know is that we collided with an enemy, and then whatever I want my player to do when that happens, we will make that happen, which in this case is respawn, which in this case is just this. So very cool that we can call a public one to call a private one. That way it's very user friendly and readable in the other classes. Player dot, well, collided with enemy. There we go. I don't know what you do. I just know that you collided with an enemy. I'm telling you I'm the enemy. You collided with me. Do what you do when that happens. Cool. So now if we save this and refresh, we can actually, we can't really test the stomp yet, but we can test when we run into him, right? When he runs into us, we are respawning, which is perfect. But if we come from the top, well, now we're inside of our chicken. Not good. So now we can actually do the got stomped. Well, what happens when it gets stomped? Well, the first thing we want to do is we want to play our bounce sound. So we can do if game.play sounds. So if we can play sounds, then we'll do flame audio dot play, and we called it bounce.wav because I renamed it to bounce, and then we'll pass in volume game.sound volume. Again, we did this in the other video. If you didn't watch that, check it out. But that's how we play sounds. We're not going to play sounds right now because every time we save, we'll have to rebuild the game. I don't want to do that. But now we're going to play the sound that we've bounced. But what else do we want to do? Well, what we want to do is we want to show that our chicken's gotten hit. And just like what we did before, we're going to take control of the state. So the reason why we made a Boolean called got stomped is now at the very top of our update function, we don't want any of this stuff to happen if our chicken has gotten stomped. So we can do if not got stomped, then I want you to do the update state and the movement. If you've gotten stomped, well, you don't exist anymore. So I don't want you to update state. I don't want you to move. I just want you to freeze and don't do anything else except for what I'm about to tell you to do. So now that we've set the got stomp to false, now we can take full control over our chicken's states and all of that. We're going to set the state current equals to state dot hit. So we've stopped everything, nothing is updating, and now we have full control over whatever else we want to happen. So we're going to set the current state to state.hit. We're going to set our player dot velocity dot y to be equal to negative, because we want it to be up in the, go up, right? Positive goes down, negative goes up. We want to bounce our player. So what we can do is we can come back up to the top. We can make a variable for our bounce, and that is going to be a static const underscore bounce height. And we're going to make this separate because there's different enemies that we have. There's one that's kind of like a trampoline, so his bounce height would be much higher than, say, a chicken. So we're going to just make it the same height as our actual jump, but this might change, which is why it's separate. And then we can just make it negative bounce height. So as soon as we get stomped, we're going to stop doing everything because we've been stomped. We're no longer logical. We're about to, disappear. I won't say the other word, but we don't exist anymore. So now I'm just being told what to do. We're going to set our current state to state equals hit. We're going to bounce our player up into the air by changing its player.velocity.y to negative our bounce height, so it goes up. And then what we're going to do is we're going to wait for that animation to play. And we can do this. This is why we used async. We're going to do await animation ticker question mark, because it could be null, is complete dot completed. And then once it's completed, we're going to remove from parent. I wonder what remove on finish does. Interesting. Let me know if that's what this does. I'd be excited to know, but I'm not going to test it. But there we go. So now when we save and refresh, we can actually, let's go back up here because I'm pretty much done. We can turn off the debug mode. We don't need that anymore. But we can full screen our game. Now when our player goes, he got hit. I'll get him next time. Oh, no, I didn't. I'll go this way. Oh, he's still after me. He's still after me. Oh, how do I jump? Nope. Okay. How do I get past the chicken? I know. I'll jump on top of him. Blink. Well, that didn't work. Well, that's not good. Bloop. Bloop. Oh, that's actually pretty cool. So maybe that's how we would do the animation for jumping on the trampoline, but that's not what I want to happen. So let's go see what went wrong so we can fix that. All right, you probably already know, and I didn't realize it. When we put got stomped equals false, we were supposed to put got stomp equals true. So silly mistake on my end, but we'll save and refresh and then relaunch it. And I gotta love coding. Little mistakes, but now when we jump on our chicken, there we go. He plays his hit animation and then he disappears. We can actually go ahead and yeah, that's pretty much it. We'll redo it one more time with sound. So we'll go back into our pixel adventure. We'll turn the sound on one more time. We'll hit save, we'll refresh, and then hopefully the sound will actually play. So when we run and jump on our chicken, we get the sound playing, and there we go. Super easy to create our chicken. Took a while, but nothing was too difficult, hopefully. But now we actually have a working chicken that we can jump on. We also realize that if we don't remove the chicken, we can just jump on him forever. So now we know how to do our next enemy. Maybe you can challenge yourself for that. There is an enemy that has like a jump pad on top of his head, so definitely check that out. Also, let me know in the comments below what enemy you would like to see next. Not sure which one we'll do, but yeah, I'll probably do some menus soon too. And yeah, I hope you guys enjoyed this video. I do want to thank you again so much for all the support on this channel so far. If you're still watching, you're really who I want to speak with. I really appreciate how much love and support you've given me on this channel. We've been able to get YouTube partnership, the full YouTube partnership, which means there's ads on these videos now, and I appreciate you watching them. I know they're annoying. Maybe get YouTube Premium. I have YouTube Premium. So I really appreciate all the support. Because of you, we've been able to make this happen. I couldn't do it without you, literally. And we're making fun games. I can't wait to do more. I'm going to start working on a whole nother game series as well. So I just wanted to take a moment at the end of the video for those of you still watching. Really appreciate it. Enjoy your chicken. Definitely make sure that you turn sounds on if you're going to play the game. Also, you can download this to mobile. I have it on my phone. I play it actually a lot now. It's a lot more fun now that we have the chicken. Definitely got to create some more awesome levels so that we can actually have a fun game, because now we actually have a full game loop. But I'll probably try to look into maybe doing some menus or something like that next, so we actually have some level selects and all that before we go ahead, dive deep, and just start making all different levels. But let me know in the comments below what enemies you'd like to see next. There's so many to choose from. They're all pretty simple though, but you just have to break down that logic, right? And that's really what it is. This chicken is super complicated. Oh, he has to see if my player's in range. He has to chase my player, get jumped on. But as you saw, we were able to break him down into just little bite-sized pieces, and it's not that complicated. You just have to think like that when you're coding. Take something extreme and complex and just all little tiny things. Very simple. So I hope you guys enjoyed this video. I'll see you on the next one. Check out the video on the screen, and I'll see you there.